T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavour, go at throttle up.
Good morning and welcome as we begin a series of briefings to provide an overview of shuttle mission STS-108 and the Expedition 4 International Space Station flight. We'll begin today's series of briefings with an International Space Station overview. With us today is Bill Gerstenmaier, the International Space Station Deputy Program Manager. He'll open up with a few remarks and then we'll take questions. So.
Thank you. As always, it's a pleasure to be here today. First, let's take a look at some pictures. We have some pictures here from the various shuttle flights. This was Space Station 1 year ago, approximately 1 year ago today. You know, the crew had just come on board. We were just beginning a permanent human presence on orbit, and it was pretty dramatic. Now here's a picture of Space Station today. You know, amazing. You know, what happened in this last year is truly phenomenal. It all worked. We accomplished what we had planned. The year was extremely challenging and complex. Some highlights of the year were we've been on orbit for 1 year with a human presence. The station mass has doubled from 70 tons to 150 tons. We're roughly the same mass now as the Mir space station was. We have 3 times the power available for researchers and 4 times more our higher data rate to the ground for researchers than the Mir space station did. Last year we performed 18 spacewalks. The station volume has doubled to about the size of a 3-bedroom house. Space Station today is the largest and most capable space station ever flown. In addition, some things are not really evident from the pictures. You know, NASA took ownership of the S0 truss from the Boeing Corporation. We took ownership of the airlock. The S4 and P4 trusses were just acquired from Boeing Corporation by NASA about 2 weeks ago. And tomorrow we'll take ownership of the P1 and S1 trusses from Boeing. These are major accomplishments of the team, and when we take ownership, we've reviewed all the paper, we've looked at the documentation, and the basic construction of the truss is ready for us to take ownership of. The truss processing down at KSC is progressing well. Last week, all power-on testing for the S0 truss was completed. So now we've powered down the S0 truss. It will not be powered up again except for a period of time when we load the final flight software in it. And we're completing the final closeouts for the S0 truss, and it's on track for the 8A flight. 2 weeks ago, 2 key payloads arrived at KSC to begin processing for the UF2 flight in May. One was a microgravity glove box built by the European Space Agency, and the other was another express rack. The Canadian robot manipulator, the SPDM, is undergoing an acceptance review in Canada tomorrow. And basically, this has just been a phenomenal year from us. The hardware on orbit has performed flawlessly. Space Station is really coming together well. All our ground processing is working out exceptionally well, and really we're basically on schedule that we had planned at the beginning of last year, and we're really at cost. So it's truly been an amazing year for us. Next year is also pretty impressive. Here's a picture of Space Station a year in the future. The things you can see in this picture that's new is you can take a look at the trusses across the space station. They start with the S0 truss in the beginning, in the middle, and then off to the left and right are the S1 and P1 trusses with the radiators extended aft. So again, we're going to have 19 spacewalks planned for station next year. We're going to add about 50 tons of additional hardware. That truss is about 133 feet in length, and it'll be the place where the solar arrays get added in the following year, along with reconfiguration of the space station. Now we'll take a look at this in a series of animations. This kind of shows where we started a year ago, and then we'll just kind of progress through and add the components and elements that we did through last year. You can see the solar arrays getting added, the laboratory module being added, added the airlock, the Canadian arm, and then we'll start progressing through the trusses that come next year. You'll see the S0 truss, the starboard truss, the port truss, and then the other truss shows up. So again, amazing series of time. Last year to this year was phenomenal, and next year is just every bit as challenging. Let me talk a little bit about UF1. and you'll get a lot more detail in the briefings coming throughout the day. And I'll talk a little bit also about this past increment. You know, this last increment was a little different than our previous increments, increment 1 and increment 2. This time we had no shuttle flights during this increment. You know, we knew this was going to focus on our research activities and focus on our Russian assembly activities. And again, this increment occurred exactly as we had planned. You know, the launch started on August 10th. We added the Russian docking compartment on September 15th. We've done 3 EVAs to outfit the docking compartment on October 8th, the 15th, and then yesterday we did another successful EVA to give auto docking capability to the newly added docking compartment. Again, those EVAs have gone flawlessly. They've been extremely well orchestrated with the Russians. We've had good cooperation with the Russians on these EVAs, and the overall relationship between the control centers is really at the best it's ever been. We had the Soyuz exchange back on October 19th, where we brought up a new Soyuz return vehicle. Progress 5 docked on August 21st, and we're going to bring the new Progress up on November 26th. Again, this increment has gone just the way we've anticipated it. From my perspective, it seems like it's just a short time that Frank went up, and we're already talking about changing the crew and changing Frank and the crew out. Maybe they don't see it that way, but from my perspective, it went by very fast and went very well. Again, you know, it's hard for me to convey to you the technical complexity of what we've just done in this last year. You know, I try to do it by showing you the pictures. I describe to you the mass numbers, but that really doesn't describe the enormity of what we've just accomplished. It's much more than just the mass and the complexity and the technical things. It's just a lot of intricate software coming together, electronics, wiring, ground processing. All of this is really just amazing to me that this has all come together. And again, I think we sometimes take for granted the technical excellence that we've really achieved and what's occurred during this year. You know, it doesn't just happen. It happens through the hard work and dedication of a lot of people on the team. And there's a lot of folks that work extra hours and spend extra time and spend weekend times, spend yesterday's holiday monitoring the EVA. All that just comes about because of the dedication of this team. And I really can't thank enough all the people that work on Space Station and all the people that tirelessly work to keep Space Station flying. So I want to thank the people that work on Space Station, thank them for their hard work, thank them for the technical excellence this last year. We look forward to next year, and I look forward to your questions now.
Good morning, everybody. Glad to be here this morning. We've got a very exciting mission coming up. We are Going to change out the crew on board the space station and carry many scientific experiments up on this flight that's called Utilization Flight number 1 for the space station operations, and have many pounds of food, water, clothes, and the other necessities of life on board the space station. In this role, those of us that work in the shuttle flight control team are in the position of the delivery truck drivers. But oh, what a delivery truck we've got. I'm going to talk a little bit about what is on board the shuttle, and then Sally Davis, who is the overall lead for the operation for both shuttle and station while we're docked, will talk a little bit about what we're doing during the dock phase. Let me just say, first of all, I'm an engineer, and I can't get by without giving you some numbers and statistics. STS-108, utilization flight number 1, will be the 107th flight of the Space Shuttle. It is the 17th flight of Endeavour, the 2nd flight of the Raffaello multiple-purpose logistics module. It's actually the 4th flight altogether of those modules. It is the 12th station flight by the shuttle, and we are, as I said, exchanging the crew. We have 11 days in our mission with 1 EVA planned. The spacewalk is going to put some thermal blankets on the beta gimbal assembly that rotates the solar arrays, and you'll hear all about that a little bit later today. If I could have the picture of the crew. We're carrying up 7 people on board the shuttle and returning with 7 people, but they're not all the same. Across the top row of this picture, you'll see the shuttle crew. On the left is Dan Tanney, who is Mission Specialist number 2, the flight engineer during ascent entry. He's also extravehicular EVA number 2. Next to him is Linda Godwin. She's Mission Specialist number 1. She is the load master in charge of everything that gets transferred from the shuttle to the station and back. She's also EV1 on the spacewalk. You'll see her with the red bands on her spacesuit. Next to Linda is Don Goree, who is the commander, who is also takes on the role of the IV, or internal person that directs the spacewalkers on this very small shuttle complement crew. And on his right, on the top row, is Mark Kelly, the pilot, who also will be running the shuttle robot arm on this flight. On the left-hand side, you'll see the Expedition 4 crew that we're carrying up. In the center, Yuri Onofrienko, the commander of the Expedition 4. On the far left, Dan Birch, and the center left is Carl Waltz, all the Expedition 4 team that's going up on our flight. On the right, currently on the space station, the Expedition 3 team led by Commander Frank Culbertson in the right center, and on his left, Mikhail Turin, and in the far right, Vladimir Volodya Dezhurov. On this flight, we have a number of flight directors. Let me just describe the shuttle flight director team. The launch and landing flight director for this flight will be Leroy Kane. I will be operating the Orbit 1 shift, which is basically the crew mornings in mission control. In the afternoon for the crew, Paul Hill will be the flight director on the Orbit 2 team, and Kathy Kerner, our rookie on this flight, will take over the planning shift while the crew is asleep. I think we have a little video of some of the highlights of the flight, if we could roll that. Here we come up to the station from below and behind, pulling up in front to dock and preparations. Coming down the velocity vector from the front of the station to dock on the laboratory, Destiny module. Very familiar scene. We've done this several times. This will be our standard for many flights to come. And we'll just keep rolling that tape if we could. I think we had a picture of the payload bay, which is what I was going to talk about next. Okay, well, let me talk a little bit about the payloads. Okay, here we go. Payload bay. In the front end of the payload bay, we have the shuttle docking system, orbiter docking system with the airlock. Coming up on the sidewall, you see 2 gas cans, those getaway special cans. The forward one is Utah State 7 experiments, and the back one is a NASA combustion experiment. The multiple application customized hitchhiker Mach 1, carries a number of payloads, probably the most interesting of which is the PSRD, the prototype synchrotron radiation detector, and a number of other experiments. We have a deployable, a Starshine 2. We last deployed that on STS-96. I'll talk a little bit about that more later. A multi-purpose logistics module, Raffaello, making its second flight. Susan Voss is going to tell you all the things that are inside that. And in the back, the lightweight MPES carrier carrying even more experiments. The name of this flight is, after all, utilization, and we do intend to make best use of every inch of the payload bay. Let me give you a few words about some of those experiments. In the gas can, so we are carrying a collide experiment, which is investigating collisions into dust, which simulates meteoroid or asteroid impacts on planetary bodies. We have in the getaway specials, the Pennsylvania State University is going to be germinating plant seeds and growing plants in space. As I said, Utah State University has got 7 experiments. Also on the LMC, we have a Swedish corporation experiment that is investigating Marangoni flows, which are very weak flows in matter. We have an Argentine corporation, an association that has 7 experiments in a gas can. We are doing combustion research. We have a technology demonstration on refrigeration in space, pulse cooling going up in a getaway special can. And we have 2 getaway special cans that have student experiments that allow high school students to perform experiments in space. In addition to that, as you'll hear, we are carrying 2 major experiments in the mid-deck of the Space Shuttle, the Commercial Biomedical Testing Module and the Avian Development Facility, both of those looking at how biological systems develop in space. And we have 3 additional powered payloads in the shuttle mid-deck that we're carrying up to the space station, and we'll be bringing back 3 powered payloads from the space station into the shuttle mid-deck and keeping them powered on return to bring their science home. And again, I think Susan is going to tell you a little bit more about that. We have a number of other experiments that are technical in nature on board the shuttle, looking at how the global positioning satellite system could work both for the shuttle and for the space station lifeboat system. We are going to be running a number of medical experiments as well. So it's going to be a busy flight. I wanted to mention just a word about the Starshine. We have some more video, which is very interesting, the Starshine deploy coming up in a little bit. People call it the sparkle ball. It really is something that's been assembled by students around the world that have glued small reflector mirrors on this passive satellite that we eject from a gas can after undocking from the space station. The purpose of this experiment is for students, again, school-age students, to observe this very shiny object in low Earth orbit and learn from that how orbital mechanics work, make observations on how atmospheric drag affects satellites in low Earth orbit. It's just a fascinating experiment. We first deployed that on STS-96 on one of the early shuttle assembly flights, and it was visible for about 6 months before it re-entered, and we expect a similar lifetime this time around. Finally, I would like to remind everyone that as the administrator announced, we are carrying a number of items from the September 11th Honor Fund. We are carrying 10,000 U.S. flags, 3 full-sized U.S. flags from the World Trade Center and the Pentagon. We have a number of other items, and we can expect during the flight there will be a commemoration event, and those items will be given out to the families and loved ones of folks that were involved in the September 11th tragedy. And with that, let's see, I'll just note that on our day-by-day flight plan, we're starting off with a normal launch and set up housekeeping on flight day 1. Flight day 2, we rendezvous, maneuver, and check out the robot arm on the shuttle and the spacesuit equipment. Flight day 3, we dock and open the hatches. Sally will tell you what we're doing while we're docked. Flight day 10, we undock, fly around to about a rev and a quarter, around, have a little bit of off-duty time for the crew that by that time will have really worked hard and be somewhat
And the Expedition 4 crew has to look forward to 2 more shuttle dockings. 8A will show up toward the end of March, and then UF1 the beginning of May. There'll be 1 more Progress launch, a Soyuz taxi crew in April, where they'll swap out the Soyuz. They have many experiments to conduct. There are 2 Russian-based EVAs, and right now we've got 2 placeholder EVAs after Assembly Flight 8A to complete any tasks that have not been finished before the shuttle and on 8A. As far as handover goes, the most important part of handover is getting the Soyuz seat liners installed and checking out the entry suits, which are called the Sokol suits. This will all happen on Flight Day 4. And they do it in a specified order. However, it's all pretty much in 2 or 3 hours. So there's not a lot of difference between when the first person's seat liner is installed and the last person's. Carl Walls and Misha Turin will go first to swap out their seat liners. Then the Soyuz commanders and Anna Frienko, who's the station commander, will swap theirs out. That's Yuri Anafrienko and Mr. Dezhurov will trade their seat liners. And last, Dan Bursch and Frank Culbertson will swap theirs out. We also have a complement of flight directors in the station flight control team. I will be on Orbit 1 with Wayne. Orbit 2 will be headed by Bob Castle. Orbit 3, we also have a rookie, John McCullough, if you could call him that. John has done many, many shifts on the Expedition 3 flight. So like everyone else in the station flight control room, we're getting a lot of mission execution time under our belts. And in Moscow, don't want to forget, we're sending a flight director over. Kelly Beck will go over. I think it will be her first trip to Moscow, but we found that having a flight director in Moscow really helps facilitate discussions on any technical issues that may arise during the mission. As far as handover, talking in a little bit more detail about that, this will be the 3rd time we've done a handover. And every time we do it, we learn a little bit more about what we did well, what we didn't do well, what works, doesn't work. And some of the things that we've learned are how long exactly do we need for the crews to be spend time together discussing how equipment is set up, where things are stowed, those kinds of things. And we've decided about 12 hours per crew member is just about the right number. And we've been fortunate on this flight, we were able to schedule 12 full hours for them. If we can, we will try to get an additional 4 for each crew member, but right now the timeline is full with other higher priority activities. One of the other things we got from several of the crews is it's helpful if, rather than just talking about things, if you can actually do maintenance tasks and show the oncoming crew members how they work, how the hardware works, how to interpret the pictures or procedures or whatever they're using to conduct their daily maintenance. Some examples of that are we'll be taking some water samples from some of the systems. We hope to be able to take out and replace at least 1 utility outlet panel and bring that home for refurbishment. And one of the key tools that the crew uses is an operational local area network series of computers that are chained together in this network with file servers and video capability. And the crews have become very reliant on that network to be able to do their daily functions. And as you might imagine, takes a little bit of care and feeding to make sure that thing is always working correctly, including rebooting a lot of the laptops day by day. One of the other things we learned, probably this is the biggest lesson, is MPLM packing and unpacking. We're doing something on this flight that 7A1 did first, and they call that the bucket brigade. And if you'll roll the tape, I think we're going to see the MPLM getting installed first. This seems to take a long time in the video, but it's really very fast. In real life, this takes a couple of hours, very slow and deliberate. And then we'll move on to the video after you see the MPLM berth there to elaborate on what we call the bucket brigade. What they did on 7A1, and you'll see the video here, is they have a crew member in the MPLM. The load master will be at the hatch of the MPLM accounting for what's coming out of the MPLM, and you see the items coming out there. And the person in the node will then send whatever the item is to the appropriate temporary stowage in the node, in the airlock. This is the FUB you're seeing there. And those will stay tent stowed until the crew can have time to put them in their permanent location. Do the same thing, loading the MPLM up. You see Jim Boss there in the airlock, giving the expedition, the 7A1 crew members items to put in the MPLM. It seemed to work very well. With one addition, we're going to be using the barcode readers, we hope, if they're working the way we are hoping they will work, to document the temporary stowage location. So when the Expedition 4 crew gets ready to put those in their permanent location, we'll know where to start looking for them. One of the other things we learned from MPLM is we're expecting to take about a day to unload the MPLM and temp stow everything, but it will take several days to load it back up. And we found that placing emphasis in the timeline on loading the MPLM works best for efficiency of the crew. One of the other things we learned with respect to all of the cargo that you see there is that we need to decrease the crew's workload after shuttle undocking for a couple of weeks so that they can acclimate to zero-G, they can get their bearings in the space station, and they can take all those items that have been temporarily stowed all over the station and put them in their final location. To say a little bit, going back to the documentation about the EVA, this EVA will be on flight day 6. We're expecting it to take about 4 hours. However, the primary purpose of the EVA is to install thermal blankets on the beta gimbal assembly motor, which has a very long name and a funny acronym called the BROOM. It will involve parking the arrays in one position. The crew will go out with the blankets, wrap them around these motors, and then we'll be able to rotate the arrays again after the thermal blankets are on. This will give engineers a couple of months to study the performance of the beta gimbal assembly and see if they're performing better with the thermal blankets around them. While they're out there, and if there's time available, they will do some get-ahead tasks. They'll retrieve some tools needed for the 8A EVAs, get a blanket for an S-band transponder, and bring that in. They're going to work on one of what's called the 4-bar linkage. We did one of those on array 2B during 5A1, and we'll get the second one done on the other array, hopefully at the end of the EVA. And then we're going to take some photography if there's any time left. There was some noticed micrometeoroid orbital debris hits in a couple of components in the station, and we're going to hopefully get some pictures of that. And if you'll roll the tape again, we'll talk about the final configuration of the station. There you see it. And it goes faster than I can talk. At the front there, you see the Destiny Laboratory. And they're going to show you the truss. The P6 truss, of course, will be up toward the top of that during the EVA. Destiny Laboratory, Unity Node, PMAs, everywhere you look. There's the MPLM when it's installed on the nadir of the Unity node. The Russian segment toward the aft, Zarya, Zvezda, progress on the FGV nadir, the new docking compartment. Again, service module progress at the back there, and our joint airlock called Quest, and of course Canada Arm 2, or the big arm as we like to call it. And with that, that's the configuration we'll be flying. Of course, the MPLM we'll put back in the shuttle bay, but that's the configuration we'll be flying with the exception of a couple of shuttle visits. And that, in a nutshell,
And good morning and welcome back to the Johnson Space Center for our STS-108 briefing on the spacewalk planned for this mission to the International Space Station. With us today to outline this latest spacewalk in support of the assembly and maintenance of the station is the lead EVA officer for STS-108, Keith Johnson. Keith?
Thank you. Let's see, this is the first EVA, I guess I should say the only EVA we're going to be doing on STS-108 will be the 25th shuttle-based EVA dedicated to the International Space Station, and the 30th overall ISS assembly and maintenance EVA. Our crew members for this mission will be Dr. Linda Godwin and Dan Tannian. You'll of course meet them later. Linda will be EVA 1, and she performed a 6-hour EVA on STS-76 while Dr. Meir. This is Dan's first flight, and he will be EV2. The mission commander, Dom Gorey, will be performing the role of our IV crew member during the EVA. We spent the majority of our training preparing for the change out of the bearing motor roll ring module, commonly referred to as the broom, and I'm sure you heard Sally talk about the reason why we decided to go to the beta gimbal assembly cover. We experienced with the broom higher than expected current during rotation, and again the engineering community recently suggested that the higher current could be caused by thermal cycles from the day-night passes. And the solution to that is installing blankets on the beta gimbal assembly housing on both the port and starboard side. And I have a video showing how we plan to install these blankets, so if we could start that right now. In preparing for the broom EVA, we had to decide if we were going to use the shuttle or the station airlock. And as Sally pointed out, the broom, which is already on orbit, is about the size of a medium trash can. So the shuttle airlock was chosen due to its additional volume. Also, there were the concerns about the station system's power downs, which are also played in on the decision. And the image that you see right here is the position that we will have the arm in when our crew members come out of the airlock. When we decided to go with the blankets instead of doing the change out of the broom, we'd already done most of our training using the shuttle airlock, so we've continued down that path. Linda's going to leave the airlock carrying the starboard or the 2B BGA blanket, and Dan will have the port blanket. And you can see in this picture, this is where they are coming out, translating along the sill, and attaching their safety tethers to the shuttle arm handrail. With their safety tethers attached to the handrail, it allows them to remain tethered to one place throughout the EVA, and they don't have to perform any tether swaps. Another thing they'll be attaching when they come out of the airlock are 2 circuit interrupt devices, which will be tethered together. And these are pre-positioned on the Z1 truss as a get-ahead for the ISS-88 flight. Linda will tether these to the shuttle arm, and we'll leave them there until they're ready to be moved later on. Once they've attached to the arm will translate up from the sill of the payload bay up to the early ammonia servicer, which is about halfway up the P6 truss and is about as far as the shuttle arm can take them. And in this picture, you can see one of the crew members on the early ammonia servicer. Linda and Dan will use numerous handrails on the early ammonia servicer to translate onto the P6 truss and start their way up the zenith or the top face of P6. Linda goes up the port forward edge of the integrated equipment assembly, or IEA, and Dan translates up the starboard aft edge, as you can see from the blinking handrails there. It takes about 5 minutes for them to translate from this point up to the top. Once they're at the top of P6, the first thing Dan is going to do is remove the floating potential probe from its current location and move it to another whip socket to provide more room to work on the starboard blanket. After that's out of the way, the crew translates into position to install the port blanket first. In this view, you can see both beta gimbal assemblies, which are the small light green cylinders to the inboard of the large white mass canister. And we'll start off with the one to the right in this image. Here you can see the crew in the neutral buoyancy lab at Johnson Space Center training to install the starboard beta gimbal assembly cover. We perform this task free-floating throughout the entire EVA, and they'll work together to install each of the blankets. You can see that they work around and they adjust and pull it into position. Later on, I've got video that shows exactly how the attachments are made. It's a little bit difficult to see in the NBL footage. It takes roughly 20 to 30 minutes to install each of the blankets, so the overall task will take a little over an hour to an hour and a half to perform. The cover itself is made up of a large rectangular piece and a hinged circular lid. This is a close-up of how the blankets are installed. The crew installs 2 straps around handrail standoffs, and they come up around and attach back on Velcro patches. And then they start unrolling the blanket around. There are 9 layers of MLI on the blanket itself. And as the crew is bringing it around, they try and get it as tight to the BGA housing as possible. Once it's all the way around, they match some Velcro to corresponding pieces and pull it in place. There are 2 additional straps that go around other handrail standoffs on the other side to help secure the far side of the blanket. Then they install the top cover, and it's form-fitted, but the crew has to pull certain sections down around the beta gimbal assembly structure and the 4-bar linkage structure. And they pull these through and tug them in place. So you can see that this is a 2-person task. It takes one person to push it through and the other to pull it down and snug it. It's also important to have as much area covered as possible.
and that'll help with the adequate thermal protection that we're hoping for. You can see here the large cable that's sticking out of the top. That's the main power cable, and it's the only one that's going to be exposed, and that's because of how high it stands up off of the broom surface. So we have to kind of pull the blanket around that and push it into place. The crew will inspect all of the Velcro interfaces and ensure that the cover is properly installed once it's fully seated. And we'll also install some additional wire ties to make sure that those straps stay in place. The highlighted area shows the next work area that we're going to. It's a 4-bar linkage on the top of P6, and I've got a mock-up to show you later. The final task of the EVA is to retrieve tools from the port and starboard EVA tool storage devices as a get-ahead for ISS-8A. The toolboxes are located on the aft face of Z1, and you can see them blinking in the picture. By bringing these tools inside, we can help reduce the initial setup and translation times for the 8A EVAs. And we're retrieving about 8 tools in support of 8A. Okay, I brought some mock-ups along with me to kind of show you what we're talking about as far as the beta gimbal assembly cover. This is a rolled-up stowed configuration that we have when we launch these. We're launching 2 of them, obviously, and they're stowed in a nice tight bundle, kind of like a bedroll. And when the crew gets these on orbit, the first thing they're going to do is unwrap them and pre-position the wire ties that I mentioned before, and then they'll roll them up into the nice tight bundle that you see right here. Once they get these out to the work site, they'll place it up against the beta gimbal assembly housing and then begin unrolling it. And one crew member will hold it in place while the other starts to unroll, and these are the straps that they'll put around the handrails and Velcro back. And you also notice that there are some black alignment marks and numbers, and this helps the crew when they're working their way around to see which Velcro patches go to which section. So once it's installed, they'll go around and they'll make sure that all the Velcro is seated and that there are no gaps, and we'll hope that that does the job that the beta gimbal assembly cover is supposed to do. The next piece of hardware that I brought along with me is the 4-bar linkage. And this, I've had the privilege of showing this hardware in the past during STS-102 5A.1. The crew went out to repair one of the other 4-bar linkage latches that didn't latch, but that one didn't latch for a different reason. You may be able to see on a close-up right here on STS-102, this little latch pin right here was not allowed to pop all the way up, and that is probably because there was some interference in the mechanism inside. So the crew came out and just lightly tapped this piece right here, and that helped for this to slide up and lock in place. But as you can see from this mock-up right here, that's not quite the condition that we've got. This piece right here is not allowed to rotate, and what we think is that these screws on either side might have loosened and didn't allow this to rotate fully. So what we are doing is we're bringing up with us a pair of Shuttle vice grips, and we'll use this tool to interface on a square part of the bracket. I don't know if we've got a good camera angle here. Let's see. This square bracket inside is part of the drive shaft, and what we hope to do is take the vice grips and put them on and then rotate this to get the unit to latch. And so what we plan to do is have Linda go up with the vice grips. She'll install this tool on that center part and rotate it, and that'll allow this to latch. So in conclusion, I think our EVA team is confident about our preparation for this EVA. We're excited and looking forward to another successful International Space Station.
Good afternoon and welcome to the pre-flight briefing for the Expedition 4 crew that will be traveling aboard STS-108 to the International Space Station for their 5.5-month stay. We'll begin today with some short introductions and then statements from the crew and then Q&A. To my right, I'd like to introduce the Expedition Commander, Russian cosmonaut Colonel Yuri Onofrienko, who comes to this mission as a space veteran, having spent about 6 months on the Mir as commander on Mir 21. And with that, I'd like to turn it over to Yuri so he can introduce his crewmates.
On the right of me, you can see Carl Waltz. He will be a flight engineer during our flight. Before he had 3 flights on STS and orbiter program. Second flight engineer is Daniel Birch. He also had before 3 space flights. During our mission, we will have 2 spacewalk, 2 space cargo ships, 1 space shuttle, and maybe more detail. If you will have questions, we can answer you all your questions.
Okay, and with that, I'd like to turn over to the crew for any statements that they might like to make. Carl?
I'll just like to talk a little bit about the EVAs that we have. We have 2 EVAs using the Russian Orlan spacesuit. It'll be very similar. The look will be very similar to what you saw last night that Volodya Dezhurov and Frank Culbertson did. We'll be going out of the Piers docking compartment. The first EVA, we will relocate this. We will use the existing Strela cargo boom to relocate the Strela boom, which is stored on PMA-1, and we'll move it either to the docking compartment or possibly to the FGB. So that'll be the first EVA, and Yuri and I will perform that spacewalk. The second spacewalk will be done by Yuri and Dan Birch, and they will be installing some thruster deflectors and some external experiments and ham radio antennas on the aft portion of the service module. So it should be 2 very exciting EVAs, and we're looking forward to those. There's also the possibility of some EVAs out of the Quest airlock after 8A, and that would be sort of to supplement what the 8A EVA teams will do. Anything that is left over we'll be able to pick up. We've been fully trained on all the tasks for the 8A mission as well, so, and we're ready to help support that. And of course we'll be supporting the 8A EVAers in a IVA role, getting them suited up and also moving them around. And so I'll pass it over to Dan. He could talk a little bit about the SSRMS.
Like any crew, also on the expedition crew, we tried to split up the responsibilities. Of course, Yuri's the commander and he gets to be responsible for everything, but I mainly have been dealing with the robot arm, and the station arm right now. The first use that we'll probably have of it after we're on board is actually during UF1. There'll probably be some camera support on the EVA that they're scheduled to do on UF1. We also have a contingency use for the arm for the MPLM install and uninstall if something happens to the shuttle robot arm. For 8A, the S0 truss comes up, and Ellen Ochoa has been training on the 8A crew for using the station arm as well. So we'll be working with her to complete the S0 install, and also all 4 EVAs have extensive arm support where the crew member is actually on the end of the arm, which will be the first time it'll be used in such a capacity. On UF2, the MBS, the mobile base system, which comes up and gets attached to the mobile transporter, that'll be taken out of the the payload bay also on Endeavour on UF2, and Carl and Peggy Whitson will install that on the mobile transporter, and as well there'll also be some EVA support. We haven't talked much about payloads. I know that you all have gotten a briefing earlier about that, but some of the experiments that I'm prime on include ADVAS, which is a plant growth experiment, also BPS, which is another plant growth experiment. We have several protein growth experiments, and also several experiments that we have where we're basically, how should I say, test subjects, and one of them is a pulmonary function experiment that we'll be doing, which we've already done pre-flight. We'll be doing it in flight and also before and after EVA. They're extremely interested in what happens in the reduced pressure when we go out on a spacewalk. I think that just about covers it.
I guess one of the other things that we'll be doing a lot of repair work and retrofitting of equipment inside the space station. We have new outlets that we'll be installing during the increment. We'll also be putting in some new solid-state memory units for the CNC MDMs. We'll be putting a new chassis on the treadmill. It's getting a lot of work up there, and so we need to replace it every now and then. And on the Russian segment, we have a new air conditioner that we'll be installing and a new air cleaner. It's called the Patok.
Welcome back for today's Expedition 4 overview briefing. On my right is Susan Brand, Expedition 4 Increment Manager. Next to her is John Urey, Expedition 4 Lead Increment Scientist. And next to him is Tim Horvath, Expedition 4 Lead Payloads Operation Director from NASA's Marshall Space Flight Center in Huntsville, Alabama. Susan?
Welcome, and thank you for coming. I'm excited and I'm looking forward to the start of Increment 4 in the next couple of weeks. During Increment 3, we've been using the space station to conduct on-orbit research, and at the same time, our Russian partners installed a docking compartment installed an airlock called the docking compartment. At the same time as well, we've been looking at the performance of the space station and assessing its readiness for continuing on with our assembly sequence. First chart, please. The Increment 4 will begin with the launch of UF1 on November 29th, and it will end with the landing of UF2 in the May 2002 time period. Throughout the entire on-orbit stay of the crew, they will be conducting research. At the same time, we will be preparing for the next phase of major assembly tasks, specifically the construction of a large truss that includes the solar arrays, the enhanced electrical power system, thermal radiators, and the mobile transport system. This phase of construction will occur over the next 2 years and will start with Flight 8A, which is about 2/3 of the way through this increment. In addition, the Expedition 4 crew will have several space vehicles that will come and go during their on-orbit stay. In the February time period, a Progress vehicle will deliver cargoes and supplies. The Shuttle 8A will arrive in March. And in April, a 3-person visiting crew will bring the 4 Soyuz rescue vehicle to the station, and then about a week later, that same crew will take the 3 Soyuz back down to the ground. Next slide, please. The 1 Russian and 2 Americans who make up the Expedition 4 crew are scheduled to spend about 5.5 months on orbit. The commander, Colonel Yuri Onofrienko, is a cosmonaut from the Russian space program. He has served as a commander on the Russian Mir space station. He spent 6.5 months during the Shuttle Mir program on the Mir space station, and he has performed 6 EVAs out of the Mir space station. The 2 American astronauts seated in this photo are Dan Bursch and Carl Walsh. They both are veteran astronauts and each have flown on 3 prior shuttle flights. Dan Burch served as a mission specialist on STS-51, 68, and 77, and he also gained some spaceflight experience using the Shuttle remote manipulator system to capture and recover an orbiting satellite. Carl Walsh served as mission specialist on STS-51, 65, and 79. And on one of these flights, he performed a shuttle-based EVA, and on another flight, he also got a trip to the Mir space station as a shuttle as a shuttle crew member during the Shuttle Mir program. When the Expedition 4 crew arrives at the space station, almost immediately they will be starting to perform on-orbit research programs, which will continue throughout the entire increment. Early during the increment, they'll also be getting familiar with their new home as they move in and unpack the 2,800 pounds of cargo that were delivered by the 6th Progress, as well as the 5,500 pounds of cargo that are delivered by the Shuttle US-1 flight. These two flights, as well as the 7th Progress flight in mid-February, will provide most of the supplies required by the increment crew for the 5.5-month duration. Next video, please. In January, the crew will perform 2 EVAs using the docking compartment airlock. The purpose of the first EVA is to install the second of 2 cargo booms called Strela on the docking compartment. The installation of the first cargo boom, shown in this video, was performed by the Expedition 3 crew. The second Strela was actually delivered to the ISS and temporarily stowed on PMA-1 over a year ago. With the completion of the docking compartment and the first Strela installation and activation, the ISS-4 crew will now install and relocate this second Strela boom from its temporary location to its permanent location on the docking compartment. The purpose of the second EVA is to install a variety of external exposure plates on the service module, as well as a TV system and a second set of ham radio antennas. Next diagram, please. Following the docking compartment EVAs, the crew on the ground will start to focus their attention on ISS preparations for Flight 8A and the installation of the S0 truss. In the February and the March time period, a new set of station software that is required to support both the increasing size of the space station as well as the growth of the electrical and the thermal systems over the next year will be installed, activated, and tested prior to the arrival of Flight 8A. The station joint airlock, as well as the station remote manipulator system, will also be tested with the new software to confirm compatibility and operability of these systems prior to their use on 8A. Next video, please. The S0 truss will be installed on the station lab during the Flight 8A dock time period using the U.S.-provided station joint airlock and the space station remote manipulator system. When the S0 truss and the mobile transporter's assembly tasks and activation tasks are complete, the station will have the first component of the truss structure installed on the station and ready to receive the next set of truss-based components during the subsequent assembly flights. All the assembly flights are exciting, they're challenging, and they're valuable to the capability and overall functionality of the space station.
And good morning, welcome everybody. It's good for me to be back here again, this time talking about the Expedition 4 research program. And during Expedition 4, we'll begin the busiest, most diverse, and the most complex research program we've ever attempted on the International Space Station to date. So I'll talk about some of the details in a minute. I also would like to talk a little bit about where we've come so far with the first 3 expeditions, as we are continuing to build and operate a world-class research facility on orbit. If I could have the first slide, please. Over the past year, the ISS has grown both in size and capability, and so has the research program. And this little collage you see there, a photo from each of the first 3 expeditions. We've come a long way from our initial trio payloads we flew to the station back in September of 2000. We added the U.S. Lab Destiny early this year, and began its outfitting. We now have 5 research racks on orbit, and research has been going on continuously for the past 8 months. Supporting on the ground is the Payload Operations Center in Huntsville, and you'll hear more about that from Tim Horvath in just a moment, as well as the remote telescience centers across the country. If I could have the next slide, please. What you can see here also is a buildup of the number of payloads through Expedition 4, and you see a big upturn there with Expedition 4. What we've done so far is we've operated 28 different payloads through Expedition 3, many of which are still in progress today and will continue into Expedition 4. These have supported 41 separate investigations from the U.S. academic community, from government and industry, as well as from international partners such as Japan, Canada, Germany, Italy, and Denmark. We've devoted nearly 500 hours of crew time to the research program to date, and have racked up more than 50,000 hours of experiment runtime. We've placed more than 4,200 kilograms of research hardware on orbit, and have returned more than 500 kilograms of hardware, samples, and other data products back to the ground. And with the conclusion of Expedition 3 on UF-1, we'll be bringing back an additional 400 kilograms or so of additional research material. If we could move to the video clip, please. This was a clip taken by the Expedition 3 crew about a month ago. It's a very good tour of the research facilities on board. First one you see here is the Human Research Facility. This was the first research rack we put on orbit back on the 5A1 mission last March, and it is to support our human life sciences investigations. Up above there, essentially on the overhead of the ceiling of the lab, we have 2 express racks. They came up on a 6-day flight in April. Express Rack 1 has been essentially operating continuously since late April, supporting about 10 different payloads such as protein crystallization experiments and others as well. Express Rack 2, which came up on that same flight, is the active rack isolation system. We have been performing a series of tests to characterize how well that isolation system works, and you see that microgravity barrier in front of that rack, and that activity will continue into increment 4 as well. It also has one of our major experiments in it as well, the protein physics of colors in space, excuse me. One of the things you see there is the shaker, which was used to test the Eris rack system. We also sent 2 additional racks up on the 7A.1 mission in August, Express Racks 4 and 5. Express Rack 4 operated for about 2 weeks, supporting a biotechnology experiment. In a short while, we'll actually be configuring Express Rack 4 to be our continuously operating rack, taking over that function from Express Rack 1. And Express Rack 5, which is not shown here, is currently just used for stowage. It will be operated in later increments. So as you can see from all this, we have a very robust set of express racks to support the variety of experiments that we've been doing so far, and we'll continue to do on Expedition 4 as well as subsequent increments. So for Expedition 4, we have 26 different payloads that will be conducted, and 7 of these are new to the ISS program, and they will be supporting 30 primary investigations to characterize the microgravity environment, to study human physiology, performing research in fundamental biology, which will be a first on this expedition, doing some materials processing, as well as exposure of materials to the environment, biotechnology. There's some very active commercial endeavors on this expedition, and we'll continue our sciences as well as our education and outreach program. We'll be bringing up an additional 750 kilograms of research hardware during this expedition. That's both on the UF-1 and on the 8A missions, and returning about 730 kilograms of hardware and samples on 8A and on UF-2. And we're estimating we'll be devoting about 300 hours of crew time to research during the expedition. If I could have the next slide, please. Fundamental biology, they will see their first experiments on this expedition. There's 2 of them. One of them is a plant biology experiment called the Biomass Processing System, or BPS. It's actually going up on the 8A flight, will be operated on board and then come down on UF-2. It's to validate the plant growth system so they can maintain the right environment to grow plants, and also a science experiment to grow dwarf wheat plants inside the unit, and they will be studied for their photosynthesis and metabolism. We also have an experiment in avian embryology. It's flying as a sortie on the UF1 mission, so it will not actually cross over into the ISS. It's to validate the operation of the facility, which was built by a company called Shuttle in Greenville, Indiana. And it will study the embryology of Japanese quails. 36 eggs will be flown, and they'll be automatically fixed during the UF1 flight. Next slide, please. In the area of human life sciences, we have 7 experiments. 6 of these are continued from earlier expeditions. You see the first 3 here on the left is the H-reflex experiment, neurovestibular study, which flew on expeditions 2 and 3. We'll actually be concluding this experiment with expedition 4. The PI from Montreal, Canada will be accumulating all the subjects that he requires for the investigation. We'll continue the bone research activity. The principal investigator from San Francisco, he's already got subjects from expeditions 2 and 3. And then the interactions, the weekly questionnaire, will be continuing that activity as well. Next slide, please. The PUF experiment, the pulmonary function in space, which we started in expedition 3, will continue on into expedition 4, as will the renal stone experiment, looking at the likelihood of developing kidney stones in space. And the Xenon 1, as we call it, which is really an experiment looking at microcirculatory effects and how they might impact post-flight orthostatic intolerance that we've seen in some crew members. Next slide, please. We do have a new experiment from the Human Life Sciences. It's called EVARM for short. It's a study of radiation doses experienced by astronauts during EVA. This is an experiment specifically done to measure radiation levels inside the U.S. EVA suit. Essentially, we have little dosimeters in various locations near the eyes, near internal organs, or the blood-forming organs, as we like to call them, and the skin, and they'll be measured during EVAs, starting with EVAs on the 8A mission. And these radiation badges will then be read before and after the EVA on orbit in the data downlink. Okay, next slide, please. Okay, turning to the microgravity measurements, some of you may be familiar with some of these hardware equipment already. The MAMS and the SAMS are the 2 recording devices we've been using since Expedition 2 to record various parts of the microacceleration spectrum on board. We have had lots of data from these instruments during shuttle dockings and EVAs and dynamic events such as that. And then the ARIS ICE, which is the characterization experiment for the rack isolation system, we're continuing and actually concluding that activity during Expedition 4. So far that activity has been going very well. The characterization of the rack, it seems to be living up to its expectations. Next slide, please. The physics of colloids in space from Harvard University has been going through increments 2 and 3. We'll be finishing this up during Expedition 4, although there is a possibility that given some of the interesting findings that they've seen, we might actually extend this into Expedition 5 as well. This study has been going very well, and we'll continue this through Expedition 4. It really requires very little crew time to accomplish so far about 1,200 hours worth of experiment runtime. Next slide, please. In the area of biotechnology, we have several studies. The first one is in the cell science area. It's very similar to the experiment that we ran early in Expedition 3. It's a tissue culturing experiment. It's essentially same hardware, same operations, but we have new investigators with new cell lines. 3 investigators from the NIH, from Tulane, and from Harvard will be flying on this expedition. And in the protein crystallization area, we do have 2 studies. The PCGS test, which we have flown before in ISS to study lots of different samples outside of Marshall Space Flight Center. They'll be going up on UF1 and coming back on the 8A flight. And the PCG-EGN, which is the self-contained passive dewar that you see in the lower right-hand corner, actually making its 4th trip now to the International Space Station, capable of housing hundreds of protein crystal samples, including many that are provided by high school students. Next slide, please. Okay, in the commercial arena, we do have 6 activities. 3 of them are essentially reflights from earlier missions. What you see here, actually on the left-hand side, from the ADVASC experiment on increment 2, is the actual plants that were grown in space during that mission. It will have a reflight during this expedition with the one additional new thing to it, that it has a sampling hatch that we'll be able to take samples from the plants during the growth phase. The commercial generic bioprocessing apparatus, essentially a reflight of the Expedition 2 hardware. We had some hardware problems on that flight. We're not able to complete the experiment, and so the commercial company Bristol-Myers is looking at reflying the experiment. And also the commercial protein crystallization from Dr. DeLucas in Birmingham also is making its reflight. Next slide, please. And we have three new commercial endeavors on this expedition. First one, essentially sponsored by the Amgen pharmaceutical company in California, looking at studying a novel protein that was just discovered a few years ago called OPG that might be beneficial in the osteoporosis or the bone demineralization that we see both in crew members in space as well as some patients on the ground. The furnace you see on the bottom is a zeolite crystal growth furnace. Zeolites, you can think of them essentially as rigid sponges. They're materials that can absorb large amounts of liquids or gases, and they're used quite heavily in such industries as the petrochemical industry. We'll be using that furnace to process some samples to see if we can achieve better quality zeolites essentially for use on the ground. And the third one, called the Microencapsulation Processing System, or MEPS. This is some investigators from Texas A&M University looking at developing new encapsulation processes for making microcapsules of different pharmaceutical agents that might be beneficial in cancer chemotherapy. Next slide, please. We'll be continuing the Earth observation studies that have essentially been going on since the birth of human spaceflight. We've now added over 6,000 or 7,000 images taken from ISS to this program, and we'll be looking to continue that during Expedition 4. Next slide, please. In the area of education outreach, we have the EarthCam activity, which we've also flown on previous ISS increments, in which middle school students can choose some sites that they want to have imaged on the ground and then send commands up to an electronic camera on board and get the images back down and placed on an internet website. And we have a couple of cycles of this we'll be planning during Increment 4. And we also have an education payload activity, which will be videotaping certain activities and demonstrating different science and physics kind of phenomena in zero-G. And last slide, please. And not to forget, we did put the MISSI material samples out during the 7A1 EVA, and they continue to be out there and be exposed to the external environment. And these will actually not come back until either late 2002 or early 2003, depending on the actual launch date of the ULF-1 mission, for about a year and a half exposure to the outside environment around the ISS. So with that, I gave you a quick summary of the major activities we're doing on this increment. It is going to be the busiest, most diverse, and most complex that we've ever attempted on ISS. And once again, demonstrating that we are building and operating a world-class research facility in low Earth orbit. So with that, I'll turn it over to Tim.
This morning, I will talk a little bit about the Payload Operations Center at Marshall Space Flight Center and its role in ISS operations. The Payload Operations Center has been in use for payload operations since the early 80s, and in fact has provided engineering support for programs since Apollo. Our International Space Station support for round-the-clock operations began in early 2001 with the beginning of Expedition 2. And Expedition 4 will be the third such expedition for this type of support. First slide, please. Our Payload Operations Center is made up of high-tech communications links all around the country and around the world. We have computer systems, millions of lines of software, and truly, though, the heart of it all is the people that work there at the Payload Operations Center. Next slide, please. The Payload Ops Center consists of flight controllers, facility operations personnel, and computer support people. These are the folks that make up my team in Huntsville. Our Expedition 4 team is beginning to phase in to replace the Expedition 3 team. This transition is happening as we speak and will be complete prior to the UF-1 flight. Each expedition that we support payload ops from Huntsville, we are gaining experience and knowledge, and we are working better and improving our processes all the time to be able to support research on Space Station. We are ready to implement the ambitious research program that John just described, and we look forward to doing this on Expedition 4. Next slide, please. Our Payload Operations Center and the Payload Ops team includes not only the Payload Operations Center itself, but researchers and scientists across the country. We have to work in close choreography and coordination with 13 remote sites. We work with institutions of higher learning such as Harvard, University of Colorado at Boulder, and University of Alabama, Birmingham, the neighbors of Huntsville to the south. We also work closely with researchers across NASA centers, Ames Research Center in California, Glenn Research Center in Ohio, and Johnson Space Center here in Texas. Each investigation that we support on ISS has unique resources and unique needs. And the teamwork that has to happen among all the organizations makes it all possible. Our team to accomplish payload operations includes the crew, it includes the Mission Control Center here in Houston, it includes the Payload Operations Center, and it includes all of our remote facilities and sites. And let me give you an example of that. You've already heard this morning about the powered payloads that are in the shuttle middeck that are coming up to space station. We have some crystal growth experiments. They require power in the shuttle, they require power on the station, and we want to minimize the amount of time that they don't have power. They have very sensitive thermal limits to keep their samples at the right temperature. So the choreography that has to happen for these payloads to get transferred. Our team at the Payload Operations Center will configure the express racks. They will make sure the station has the right systems in place to support the payload operations. We will work with the control center here in Houston. We will work with the crew in space. The crew will actually do the transfer of the payloads over, install them into the express racks, make sure they're configured properly. And we at the Payload Operations Center will see the telemetry from those experiments. We'll see that they're getting power. We'll see their thermal limits are being met. And the researchers at their remote sites will also see their science data begin to flow. So that's an example of how the teamwork really plays into what we do at the Payload Ops Center. I guess to sum up, we are looking forward to great success in implementing this ambitious research program on Expedition 4. And last slide, please. And during Expedition 4, you can see periodic updates on our website at scipoc.com.
The Space Shuttle Endeavour returned to Kennedy Space Center back in March, early March of this year after landing at Edwards Air Force Base following its previous mission. It landed at the shuttle landing facility, being carried atop the 747, and was then towed to the orbiter processing facility for post-mission servicing as well as preparations for its upcoming mission. Meanwhile, the payload activities were happening concurrently. Payload processing in the shuttle processing in the space station processing facility were being conducted in September. The NPLM, and of course activities continuing on with the main engine installation on September 25th on the vehicle. Following each flight, all three main engines are replaced. And in the vehicle assembly building, the external tank is being mated to the solid rocket boosters. External tank goes on to the boosters after the boosters have been stacked on the mobile launcher platform. During crew interface testing, the crew were at Kennedy Space Center a number of times prior to launch activities. Kathy, all the crew were here at various times looking at the toolkits that they'll be carrying aboard. Linda Godwin as well as Dan Tawney. They also spent some time in the orbiter's payload bay while it was in the orbiter processing facility. The crew spent some time in the cockpit, final inspections of the orbiter's windows, of course verifying that there are no scratches or dings in the windows, using high-powered lights to do that work. And again, of course, spending time with the payload. The prime payload on this mission is the NPLM, which will carry experiment racks as well as supplies and equipment to the International Space Station. Meanwhile, again, concurrently, the Space Shuttle Endeavour being rolled back from the orbiter processing facility. On October the 24th, it was backed out of OPF Bay 1 and moved into the vehicle assembly building. Inside the vehicle assembly building, the external tank and solid rocket boosters were already prepared and ready for the orbiter to be mated to it. This is a view of the NPLM being lifted, rotated in the space station processing facility. All the experiments and so forth are on board, being moved into the payload transportation canister, which will then take it out to the launch pad. On October the 31st, Space Shuttle Endeavour mated to the external tank and solid rocket boosters aboard the huge mobile launcher platform, was being carried out to the pad by the crawler transporter. It's about a 6-hour trip from the vehicle assembly building to the pad. Payload transportation canister is currently shown here at the payload changeout room prior to the rotating service structure being closed around it. Once the RSS is closed around it, the orbiter's doors can be opened and the payloads can be installed. This is a view of the Starshine payload, one of our other payloads. This payload will be deployed following docking operations to the station. It contains hundreds of mirrors that were shined by thousands of students around the world. Starshine will be deployed. It's the second time it's been deployed from the space shuttle. And this is a view of the closing of the payload bay doors. Preparations are complete. Payload bay doors were actually closed for flight back on November the 26th. This all occurring at the pad inside the payload changeout room.
Good afternoon. We'd like to thank everybody for coming out here to greet us as we come to Florida. Just a beautiful day to arrive for a wonderful flight. This whole crew is ready to fly. Our most important mission is bringing these 3 expedition crew members up to the space station and bringing Expedition 3 home. We are ready to do that and are looking forward to a launch on Thursday night. We'll just hope that the weather stays like it is, and we're going to have a wonderful flight. Yuri's got a couple words.
Hi everybody, I'm really happy man. I'm here in Florida. I'm just have a mission flight. I haven't seen this something like this maybe about 10 years. I have a really good possibility to see my friend during flight. That was really great. I'm hope we will have a really successful flight during long duration flight. Thank you.
Thanks for coming out today to welcome us here to Florida. I'm glad to be back. My parents live just up the road in Flagler Beach. Wanted to say hi to them, and hopefully you guys can do something to keep the weather like this till Thursday.
It's okay. The other hand. Go ahead, Carl.
And just really glad to be here. We had a great rehearsal just a few weeks ago. The weather was great then. It's great today, and we're very happy to be here. Thanks y'all for coming out.
Have to move the mic down a little bit, like the Queen of England. I just want to say, after 4 years, we have a lot of homes. One of them is here at KSC, so it's great to be home back here in KSC. Of course, we got our real home in Houston, but we also have a home in Star City and sometimes in Canada, but our next home is up on ISS, so we're looking forward to going up there on Thursday. Thanks a lot.
You know, there are some places in your life that you never expect to be, and standing here at this mic is one of them. And I'm really, obviously, excited to be here. Thank you all for coming out. We can't wait to give these guys a great ride and see them off to their new home. And I guess we'll see you in a couple weeks. And hi, Mom, and hi, Jane.
Well, it's good to be back in Florida and back here at KSC. It took the effort of a lot of people to get us ready to fly, and a lot of folks here. Tremendous effort to get Endeavour ready to fly, and we're ready to go on Thursday, and just can't hardly wait. Looking forward to it.
Okay, thanks again one more time for coming out and welcoming us here to Florida. It's been a couple months since we launched the space shuttle. The folks here at KSC are raring to get another one in the air, and we're ready to go as well. Thank you very much. Okay, go. Our helmets.
NASA's next space shuttle launch is Endeavour, scheduled for Thursday, November 29th at 7:44 p.m. This is the 12th space shuttle flight to the International Space Station, carrying the Raffaello multi-purpose logistics module. Landing occurs on December 10th at 3:41 p.m. after an 11-day mission. This is the last space shuttle launch of 2001. The first space shuttle flight of 2002 is Columbia on STS-109, the third mission to service the Hubble Space Telescope. Launch is scheduled for February 14th, with landing on February 25th after an 11-day mission. To follow will be Space Shuttle Atlantis on STS-110 on the 13th flight for construction of the International Space Station. Launch is scheduled for March 21st, with a landing on April 1st after an 11-day mission. Endeavour is scheduled for launch on May 2nd on STS-111, the 14th flight to the International Space Station. Aboard will be the Leonardo multi-purpose logistics module and the mobile base system for the space station remote manipulator system. Landing will occur occur on May 13th after a 10-day mission. Columbia is scheduled for launch on June 27th on STS-107, a microgravity research flight. Landing will occur on July 13th after a 16-day mission. Atlantis is scheduled for launch on August 1st on STS-112, the 15th flight to the International Space Station. Landing occurs on August 12th after an 11-day mission. Endeavour is scheduled for launch on September 6th on STS-113, the 16th flight for construction of the International Space Station. Landing occurs on September 16th after a 10-day mission. The first launch of 2003 is Atlantis on STS-114, the 17th flight to the International Space Station. Launch is currently planned for January 16, 2003, with landing on January 26th after a 10-day mission.
Good morning, everyone, and welcome to our first countdown status briefing for STS-108. Here to bring us our countdown status this morning is Jeff Spaulding, the STS-108 Shuttle Test Director, Todd Corey, the STS-108 Payload Mission Manager, morning, and Ed Priselic, the Shuttle Weather Officer from the Department of the Air Force. And we'll begin first with the Space Shuttle status out at the pad and Jeff Spaulding. Jeff?
Thank you, George. Good morning. After a couple of months away from launching, I'm pleased to be back here today to provide some launch countdown status for the Shuttle Endeavour's upcoming launch, which we're going to bring the multi-purpose logistics module up to the International Space Station, and also we'll have the opportunity to exchange the Expedition 3 and 4 crews out while we're up there. The flight crew did arrive on Sunday, and that particular day they completed some of their final inspections and vehicle configuration checks, and they've been doing some of that throughout the yesterday and today. The flight crew work has been going well, and they're also doing some training this morning. The countdown itself began last night at the T-minus 43-hour mark, and since that time we've performed a checkout of our avionics system, and we're doing some preparations toward the loading of our onboard cryo tanks. And that work is ongoing today, and we anticipate beginning that loading up mid-shift this evening. Once that's complete, we reopen the pad from that operation, and then we get into our main engine checks and some other additional pad closeouts as we work throughout the night on those types of operations. Once the countdown proceeds to the T-minus 11-hour mark, we enter a built-in hold that begins late Wednesday night. And during that hold, we complete preps toward the power-up and checkout of our ground communications network, which is scheduled to occur on Wednesday evening. We do plan to retract the rotating service structure late on Wednesday night, and then continue pad closeouts throughout the remaining of that night in anticipation of ET load on Thursday morning. That operation generally takes about 3 hours, as is standard. Following that operation, we'll of course continue with our preparations for the flight crew arrival at the pad on Thursday, working towards our launch. Our hold periods are standard as they have been for these types of missions, with a 2-hour hold at both T-minus 6 and T-minus 3, 10-minute hold at T-minus 20, and a 40-minute hold at T-minus 9. Our launch window for Thursday is about 10 minutes in length, as they have been, and extends from 7:36 to 7:47 p.m. Preferred launch time within that window is about 7:41. Our times do change slightly based on our day of launch parameters, of course, and on the latest station position, too, as we sync up to that. We do that sync up during the T-minus 9-minute hold, and at that point we adjust our times to match the actual T0 time. The window does open about 23 minutes or so earlier each day if we were to go past Thursday. It is an 11-day mission. We do have 2 weather contingency days, as is our standard, with landing planned on the afternoon of December the 10th, which is Monday. As far as scrub turnaround plans, our hold limits for PRSD, we do have 4 days of hydrogen and 9 days of LOX for our hold limits. And of course we have our 24 and 48-hour turnaround capabilities, as have been standard recently. What this does is gives us 5 launch attempts in 7 days before we would need to stand down after December the 6th. And the reason we would stand down at that point would be for the range, as they're quite busy throughout the month of December. We do have a beta angle cutout, which comes into play in mid-December, and that spans for about a couple of weeks right into the beginning of January. In summary, the KSC processing team has done an exceptional job getting this vehicle ready for flight. I think everybody's excited to be back launching again after a few months from that perspective. And all of our flight and ground systems do look great, and we're looking forward to Thursday evening's launch. And that's all I had, George.
All right. Thank you, Jeff. And now on payloads, Todd Corey.
Well, thank you, George. Good morning, everybody. This is going to be the second flight of the multi-purpose logistics module called Raffaello. We also call the modules MPLMs. This is also going to be the fourth flight of an MPLM for the International Space Station program this year, so it's been busy for us in the MPLM world. Being a crew rotation flight, there's going to be a significant amount of clothing and food and other crew provision items that are being brought up on this mission, in addition to science experiments and supplies associated with those science experiments, as well as spare parts for the International Space Station and a variety of tools. In addition to the MPLM, we have some other payload bay carriers that are flying on this mission, and they've have a set of experiments that cover the range of, looking at biology and physics and chemistry of materials and various specimens and how they react to the space environment. And those experiments are carried on the following carriers. We have what we call a lightweight multi-purpose equipment support structure carrier. We call it LMC. And this is a Marshall Space Flight Center designed carrier that allows us to install 4 gas can type experiments. There's actually 3 getaway special canisters installed on this carrier, as well as a space experiment module. It's also like a gas can type experiment. What's unique about this carrier is that it provides what we call a launch on need capability for the space station program. In the event that there might be some type of a hardware failure on orbit, this carrier provides us an opportunity to remove one of the gas canisters on the carrier and replace that with a spare that we could fly up to the space station, and we would be able to do that change out at the pad. For this particular flight, there was nothing required in terms of a launch on need, so we'll just press ahead with the experiments that we have on the carrier. Another carrier that's on board is a Goddard provided on, it's the multiple applications customized hitchhiker payload. It has 7 experiments on board, one of them being a deployable Starshine satellite that has quite a bit of student involvement. And last but not least, there's also 2 getaway special canisters that are flying on the sidewall of the payload bay of the orbiter. And just in summary, some of our highlights out at the launch pad. We did get out to the launch pad with the MPLM, the LMC, and Mach 1 about a little over a week late, and that was due to high winds here at Kennedy. Once installed into the vehicle, we did get our interface testing completed between those payloads and the shuttle itself. And one of the first that we have here on this mission for the MPLM is that this is the first time that we've actually stowed cargo into the MPLM out at the launch pad. And some of you may recall during the Space Lab program, as well as during Space Lab, we've had the capability to stow stuff into the modules out at the launch pad, and we've done that through the crew cabin and then also through a tunnel that was attached to the module. And for the MPLMs, we don't have a tunnel that's attached to the MPLM, so we gain our access into the module from the payload changeout room. And if I could have the first slide, please. I've got a couple visual aids here to show you pictorially what I'm talking about here. This is a view. You got to assume here that the MPLM is installed into the orbiter's payload bay, and over the top of that we have what we call a payload late access platform that provides an access area to work from and has an opening in the top down into the MPLM. And on top of this access platform, we have what we call a payload late access kit, and that consists of an extendable ladder that we can put down inside the MPLM, as well as a foldable a floor that we can unfold once it's down inside the MPLM. And there's also 2 hoists that are attached to the late access kit that provide a capability for lowering cargo down into the module. If I could have the second slide, please. And this just shows a cutaway of the access kit itself deployed down inside the module. You can see the ladders extended down in, the floor has been unfolded, and it shows a couple technicians that are standing there handling some cargo. So for us, it's a great capability for the station program for us to be able to put in time-critical items into the MPLM, as well as accommodate any last-minute changes to the flight manifest for things that are flying up to the station. We did, out at the pad, install 51 cargo bags, so we felt good about the operation that we put together, and the stowage itself went extremely well, so we were very happy about that. And you can take down that slide, please. So anyhow, that was we've got that work behind us as of yesterday. All of our payload bay closeouts have been completed. The only work that we have remaining in front of us is the installation of 11 experiment lockers into the orbiter middeck. 7 of those will be transferred to the space station once we're on orbit, and they're carrying on research that's been done in the areas of protein crystal growth, plant development, tissue development, those sorts of things. We have another 4 sets of lockers that will be going up on the shuttle and staying in the middeck during the flight, and then they come right back down. And one of those lockers is carrying some Japanese quail eggs, and that's in support of an embryo development study. There's also 3 lockers that are carrying a total of 24 mice that are in support of research on osteoporosis, the bone loss disease. So some fairly significant research going on there. And then there's also going to be 3 experiment lockers that are going to be coming back from station on this flight that will be stored on the runway. And let's see, from a launch delay standpoint, in the near term for a 24-hour turnaround, we do have 4 experiment lockers that we need to remove and refurbish. And then for a 48-hour turnaround, we'll have an additional 4 lockers that we'll have to remove and refurbish for a total of 8. And in terms of long-term launch delay, we do have a requirement to get back into the MPLM within 30 days of our launch attempt here on Thursday, and that's to refurbish some limited life items that we installed into the MPLM over this past weekend. So with that, we're ready to fly, and we're looking forward to Thursday's launch. Thanks.
All right, thanks, Todd. And for the weather picture, Ed Priscilla.
Thank you, George. Good morning. As we work our way through the endless tropical season, I give you Hurricane Olga to our distant east. And currently it is creating some large swells in the recovery area, and we'll chat about that in just a moment. To the west, we do have a funnel system approaching. It looks like it will be in the Gulf of Mexico, west of Florida, Thursday evening. So the main concern we have is the possibility of thunderstorms in the Gulf, generating some anvils working their way on southwest winds into the areas. That's our primary concern with regard to the launch commit criteria here at KSC. As far as tanking is concerned, we'll probably just have some southeast winds in the local area, just a slight chance of some showers, and no concerns for tanking. For launch, could we bring the graphic up on here, please? As I mentioned, we have the concern for anvils here in the local area. That's a primary concern. Just a very slight chance we might have some local showers or thunderstorms. And given those concerns, a 40% chance that weather might keep us on the ground on Thursday evening. Looking now to the recovery area, and the concern, as I mentioned, is the seas in the area. Right now, estimating 12 to 14 feet. Currently 12.5 feet at the buoy just south of the recovery area, so we figure 12 to 13 feet right now. Now, we do have a 13-second period between the wave crests, and given these conditions, currently the recovery director has indicated the ships will go ahead and go out to their station prior to launch. Now, they're scheduled to leave at 1 o'clock tomorrow afternoon from the local area. We're going to tag up again at 11:30 and take a close look at all the conditions out there. And I'll also be working with the Navy folks at Norfolk to get some additional expertise and input regarding what the seas might be. What I'm concerned about, as long as you have the hurricane out there, a tropical system, it's going to continue to generate waves and energy, and the seas may even build even more. So we'll take a hard look at that tomorrow before the ships head out. Going to the other CONUS sites, for white sands, conditions look good. Just a ceiling at 25,000 feet, southwest winds at 8 to 12 knots. And also at Edwards Air Force Base, winds 250 at 8 peak 12 knots. And I believe looking for, let me check something here very quickly, please. Just, there's a chance of showers within 30 nautical miles at Edwards Air Force Base. We can go now to the tail sites. From Wayne Baggett at SMG. All 3 tails looking pretty good, just a chance of fog at Zaragoza. I won't go through the whole graphics for you, but right now it looks like we've got 3 good tails 2 as a minimum and possibly 3 good tails on Thursday evening. Going to the delay forecast, looks like the front will be fairly close to us, but getting quite a bit weaker here in the local area. It looks like all the energy kicks out to the northeast away from us. And given those conditions, some relatively light southwest winds at the pad, and just a 10% chance that we might have a low cloud ceiling here in the local area. So from the perspective of the launch commit criteria and RTLS, things look better on Friday versus Thursday. And from Dan Ballou at SMG for White Sands, again, conditions good there with light southwest winds. And also at Edwards Air Force Base for Friday, scattered clouds at all levels and also light southwest winds. For the tails on Friday, just a chance of some fog again at Zaragoza, Maroon, and Ben Greer, both good. So again, at least 2 out of 3 good tails for Friday if we do delay. And finally, going into Saturday, again, just a few clouds around, good visibility. Front should be southeast of us, winds at the pad 348, 8 to 12 knots, and just a 10% chance of low cloud ceiling in the local area. Kona sites, less cloudiness out there, just a little bit of wispy cirrus at both sites. At White Sands, light southwest winds 5 to 10 knots. Edwards, light northeast winds 3 to 6 knots. And finally to the tails for Saturday. And a little more iffy, Ben Greer looks clean with just some scattered clouds at 4,000 feet and a good visibility. Excuse me. I haven't lost them. I'm going to read them off to you. Here we go. Just a chance of 3 miles of fog at Zaragoza and showers over the mountains, so a little more iffy on Saturday. And for Maroon, although prevailing good conditions, a chance of showers within 20 nautical miles. And I'll conclude at that point.
All right. Thank you, Ed. We're ready now to take questions. Please give your name and affiliation when the microphone comes to you. We'll start here in the front with Marcia.
Marcia Dunn, Associated Press. Jeff, you make it sound like after December 6th, that's it. Is that so? Could you sort of give your game plan for the entire month of December?
Sure. We have, right now we have 2 constraints through the month of December. The first one is our range constraints, which after the 6th, the range is unavailable until after we enter our beta angle cutout. And the beta angle picks up about the 15th of December. And then at that point, the beta angle continues throughout the rest of the month of December into after the beginning of January. About January 2nd right now is when the end of the beta angle is looking like that will be completed. So effectively, even though something changes on the range from the items that are on there, we have up to 5 attempts, 7 days, however we are able to use those, up through and including December 6th. Now, obviously, if something moves off of the range, we'd have some more days available to us before the beta angle.
Do you have any idea what the earliest would be in January where you would come back if you had to and try again?
Obviously, we'd assess what reason it was and what repairs or whatever we needed to do as a result of our scrub, whatever pushed us and made us unable to launch in December. Looking at an approximation from a technical standpoint around January 7th or so would probably be our first, maybe the 6th, our earliest opportunities that we'd be able to shoot for. And of course, we'd evaluate that throughout December to see where that best made sense to come up.
And another quick question. Given the extra security, are there going to be any changes on launch day regarding ice teams, red teams? Are you going to have more of these people, fewer of these people? Because of the security concerns?
The closeout crew, the ice teams, and the folks that work at the pad, as far as the work that they have to do is the same as it always has been. All of their requirements are the same, and nothing has changed from their perspective. And what the items are that they need to do, the things that they inspect and look for, and all the work that needs to be performed. So those processes and procedures are in place.
Same number of people.
That's correct.
Steve?
Steve Steislaw, Florida today. Sticking with the security issue, Jeff, do you have any, or would the launch director have any control over countermeasures should a situation arise, or does that fall strictly under the Air Force's prerogative?
Well, that's something that I wouldn't be able to comment at today.
Okay. You may give me the same answer on this one, but is there a separate console also for security concerns there in the Launch Control Center, or would that information all come from the range control?
Those type of things that are specific to our security postures, I'm not going to be able to comment on today.
And I have one more quick one for Todd. I think that you probably covered this earlier, but I just want to make sure I'm clear. What work is left to do on the MPLM?
Okay, we're all done with the MPLM. We finished up our late stow last week, and as of yesterday, we finished up all of our external closeouts and engineering lockdowns that we do prior to payload bay door closure.
Yvonne?
Yvonne Martinez, WKMD. I know you all are focused on the mission at hand and the job that you always do. How much of a distraction, if any, has the elevated security been to you, if at all, and how challenging has it been to press on with the job that you do in the face of all that's going on?
Well, we've been in this posture obviously for quite some time, and the team has been very focused. We've had a number of challenges throughout the pad flow as well as in the OPF that the team has met, and concerning some of the technical additional work that wasn't planned to be performed that we had to go in and fix, for example, the main engine actuator that had to be replaced at the pad and some other things. And I think that demonstrates the focus of the team in light of the things that have been going on. In addition, senior management here at KSC has took it upon themselves to make sure that the folks are aware of what is going on. They've had numerous briefings with the personnel here, and also to assure them that their safety and security is being taken care of. So, excuse me. From that perspective, I think everybody has been focused and remains to be focused, and we've seen that throughout the flow, like I mentioned before. It's been a challenging one, but I'm sitting here today, and I think that's proof that we've been able to meet those challenges effectively.
Dan?
Dan Billow from Channel 2. For Todd, what was the late stowage on the MPLM, and are the mice coming back with Endeavour?
Okay, I'll answer your second question first. The mice will be coming back. They're considered what we call a sortie mid-deck. They go up on the flight and come back on the same flight, and they stay in the mid-deck. And for relative to the MPLM, the late stow stuff that we had, some is some time-critical items that were put into the MPLM, and these are items relative to what they call the crew healthcare system. There's various media that they use for collecting samples on orbit to analyze the air, the water, any contaminant on the surface in terms of bacteria and fungi, and they want to be able to put in the freshest samples, if you will, of that media. That's a growth medium that's used for the microorganisms. So they like to put that stuff in as late as possible in the MPLM. We also have some hardware that just didn't make some of the delivery dates, and so here we have a window of opportunity to capture some of that hardware and get it into the MPLM. Our goal is always to get all of that hardware stowed into the MPLM when we're over in the space station processing facility, but sometimes some of the hardware just doesn't make it. And here out at the pad, it provided us another opportunity to get some of that stuff in the MPLM. And then there's also, for example, some crew procedures, and those are things that they're updating, as late as possible to get them ready for the crew, and so those are put in out at the pad also. So that's the nature of the stuff that we're dealing with.
And I've got one for Jeff. Just wanted to ask you how you feel about all of the security measures that are being taken for this launch.
I think I feel like most of the folks that work here that what needs to be done has been done and is being done and will be done for the safety and security of the folks here at the Space Center. And as we mentioned here a couple of times, the vehicle will be ready to go on launch day, and we're looking forward to that.
Any further questions? All right, follow up, Yvonne.
This one for Todd. Do you see this mission as different from others in light of September 11th? I mean, you have some flags, 6,000 flags that you're flying. Are you going to do anything with those when you're up there, or is it just going to fly and come back?
Actually, I believe those are flying in the mid-deck. They're not in the MPLM, and as to what they do afterwards, I'm not quite sure what the plans are for those.
Do you see this mission as being more important than others in light of, I guess, in the sense of morale-wise for the country after September 11th?
I would have to say so. I think it shows our resolve and the fact that we press on with our day-to-day lives and keep doing the great things that we're doing here for the space program. So I think it makes a pretty positive statement for the whole country.
Steve?
A quick one for Jeff. You have your meeting this afternoon. Is there any technical issue, anything at all outstanding that could put a crimp in the schedule?
Right now, the items that will be presented at the L-2 flight rationale will be presented this afternoon, and we do expect the program managers, based on that rationale, to make the decision that we're able to go, but we'll, of course, await the outcome of that meeting to make sure that everything has been decided and determined at that point.
Is there anything that stands out at this point that would make you wonder if that's possible?
No, not at this point, not from what I've seen.
Marcia?
Marcia Dunn, Associated Press. A couple animal questions for Todd. 18 eggs, is that the right number for the quail eggs?
Well, it actually holds up to 36 eggs. There's two sections in it, 18. You can have up to 18 eggs in each of those two sections, so a total of 36 eggs.
So it's going to be full.
Yeah, this is the way I understand it, yes.
And how old are these mice? Do you know? Are they adult mice, baby mice?
Actually, I'm not sure.
Okay. And how often do you have to swap out the mice and the eggs if you start getting into scrubs?
Okay, from the scrub standpoint, the mice themselves, we get on the 24-hour scrub turnarounds, and then for the 48-hour scrub turnaround, we get the quail eggs.
More. Well, good afternoon. It sure is nice to be here again. I'm sure you would agree with me when I say that I think this calendar year has been a great year for human spaceflight. In fact, I think it's been a banner year. We've flown 6 flights, and we're getting ready to fly our 7th and ending flight for this particular year. And the team has done an absolutely fantastic job. We've completed 6 safe and very successful missions, as difficult as any that we have ever flown. And we have a knack of making them look amazingly easy. STS-108 is a little unique in that we've put together a mission that not only continues our efforts to build the space station, provide logistics, and rotate the crew, but we've tried very hard to add a complement of science in the shuttle payload bay that we can perform and implement this science on our way to the station and after we undock. So we have some 61 experiments that we've included in the shuttle payload bay that gives us some experiments that are more tuned to short duration missions rather than long duration missions. So I think we've achieved a good balance on this flight. And as you know, we'll also be carrying some special cargo as NASA's way of paying tribute to the victims of September 11th. Next year will be just as challenging. 7 flights, 5 flights to station, and 2 other flights, one Hubble Space Telescope repair mission and then a dedicated research mission next June. We'll put Columbia back to work with this new glass cockpit to fly the Hubble mission and the research mission. There's a lot of work remaining in the coming months ahead of us, and we look forward to meeting the challenges both safely and successfully. Okay, thank you, Ron. Mr. Holloway.
Oh, thank you, Ron, and good afternoon. Since last July the 12th, when I stood in Baikonur and watched the service module launch, we indeed have had an incredible sequence of events, and launched, I think if we added them all up, it'd be 19 flights or something like that. But anyway, they've all gone extremely well. A tribute to the men and women all over the world who work together to make this incredible thing that's going on orbit become what it is. And now weighs 300,000 pounds. And next year, with those 5 flights, it will grow by 50 tons. And we'll get the trusses deployed. We're on track at this point to, in the big picture, meet the schedule of building the International Space Station. Today, it's an operational system capable of doing research and doing science. There's 3 research science racks on orbit being operated by Frank Culberson and his crew. So things are going extremely well in the International Space Station, and with all the hard work of the men and women to make it possible around the world, that build the hardware, process it, and operate it. I expect that will continue.
Okay, thank you, Tommy. And Dave King.
Good afternoon. From a processing perspective, processing on this vehicle has gone very well. Pretty much met all the timelines along the way. We're at the pad as expected. Picked up the count yesterday. We are a little bit behind on getting ready for loading the PRSD system today because we had an anomaly on the payload bay door bulb seal that we repaired a bit ago. We're completing the retest on that now and expect to get into PRSD load in just a bit. So that'll pretty much put us back on the timeline if we get complete with that in the next few hours. So things are going well. We're looking forward to a great launch on Thursday evening, and the team has done a tremendous job in getting us to this point.
Thank you, Dave. And now Colonel Dick from the 45th Space Wing.
Good afternoon. The Air Force is committed to our vital role in supporting the Space Shuttle Endeavour and its crew by ensuring a secure and safe launch Thursday night. The Air Force has had this role in every mission in the history of this program, and our partnership with NASA is unmatched. Since September 11th, we have taken unprecedented but critical steps to ensure all reasonable measures are in place to protect the shuttle and its crew from any security threat, whether from land, air, or sea. In respect to air security, the most notable measure is the Federal Aviation Administration's announcement of flight restrictions for launch day. This notice to airmen encompasses a 40 nautical mile radius around the shuttle launch pad from the surface up to 18,000 feet. The duration of the restriction is from 1:45 a.m. until 8:45 p.m. Thursday. Commercial air traffic flying from surrounding major airports such as Melbourne and Orlando will not be affected. Within the first 30 miles of the zone, no general aviation or visual flight rules air traffic will be allowed. From 30 to 40 nautical miles, general aviation and VFR traffic are allowed if pilots obtain a discrete transponder code, clearance from the appropriate air traffic control facility, and maintain continuous communications with air traffic control while in the area. Along with these restrictions, working with the U.S. Coast Guard, a Mariner security zone was established 3 miles around both Kennedy Space Center and Cape Canaveral Air Force Station. For the past few weeks, we've allowed local fishermen to fish in certain areas of the zone after clearing through our security. For launch day, however, from 5 to 9 p.m., no boat traffic will be allowed in the 3-mile security zone or the launch hazard area stretching 75 miles out to sea. The launch hazard area has been a precaution taken for years to ensure the safety of the general public. Maps outlining both of these zones can be obtained from the military people in the back of the room. Finally, I know there have been many media reports in the last month of fighter aircraft over Kennedy Space Center and other units that are here to support this launch. You may have questions concerning these, but please understand that in the interest of national security, there are certain aspects of our mission that I cannot address. I appreciate the opportunity to be here today, and thank you for coming this afternoon.
Thank you, Colonel Dick. And now John Weems, our launch weather officer.
Good afternoon. On the satellite shot, if you'll notice, there's 2 weather systems that we're monitoring. The frontal system that's in the mid-south continues to move this way, and we expect it to be west of the peninsula by tomorrow afternoon through the countdown. We could get some thunderstorms developing along that front, with a slight chance of developing in the local area, but most likely the major concern will be those thunderstorms to the west over the Gulf, the upper level portion of those storms being pushed eastward back over the site. So it'll be the avoidance of Anvil. The other thing that we're looking at, just a minor inconvenience, is Hurricane Olga that's to the east of us, continues to move quite erratically. It's sort of circling around itself, and it's expected in the next 24 hours to slowly drift back to the southwest. Even though it's about 1,200 miles away from us, it's causing very high seas, the swells off the coast. This morning we have 12-foot seas off the coast, and it becomes very uncomfortable, I would imagine, for the boat that's out there, but the period is such, the distance between the swells and the time period to where I think that even it would be workable out there is just uncomfortable. As we get into a delay, we do expect that front to move through the area, so the forecast for both the 24 and 48 hours is for improving conditions both days. As far as the probability of KSC weather prohibiting the launch on the initial attempt is 40%, and for both the second attempt and the third attempt, if they were necessary, is only 10%. The primary concern, of course, on the first day will be the anvils. And if there's any concern on the second day, it would be residual low ceilings behind the front. As far as tanking, tomorrow morning or on Thursday morning, whenever they start to tank, we do expect generally good conditions and don't see any constraints to the tanking at all. As far as the overseas sites are concerned, a slight chance of some restricted ceilings at Zaragoza, both on the first and second day. Other than that, all of the overseas sites remain acceptable.
Good morning, everyone. Welcome to our Launch Minus 1 Day Countdown Status Briefing. And here to bring us the status this morning, Pete Nikolenko, NASA Test Director. Good morning. Todd Corey, the STS-108 Payload Mission Manager. Good morning. And Ed Priscilla, the Shuttle Weather Officer from the Department of the Air Force. And we'll begin first with the Space Shuttle Endeavour status out of the launch pad and Pete Nikolenko. Pete.
Thank you, George. Good morning. I'm pleased to be here today to provide countdown status for the launch of the Shuttle Endeavour. The countdown is continuing in progress. Our work is right on the timeline, and we are tracking no significant issues. Yesterday, we completed the checkout of our avionics systems, and we also completed the servicing of our onboard fuel cell cryo storage tanks. We reopened the pad early this morning, and we continue now with main engine systems checks and pad closeouts. Yesterday, we also closed the payload bay doors for flight following a slight delay for a tape repair on the debonded bulb seal on the aft mid-body bulkhead. As the countdown proceeds to T-minus 11 hours, we will enter a built-in hold that begins later this afternoon. During that hold period, we will power up and check out our ground communications network early this evening. We plan to retract the rotating service structure just prior to midnight tonight, and then continue pad closeouts throughout the night in preparation of ET load Thursday about mid-morning, which should take about 3 hours to complete. Following ET load, we'll continue preparations for flight crew arrival at the pad later Thursday afternoon. Our launch window for Thursday extends from 7:36 to 7:47 p.m. with a preferred launch time within that window at 7:41 p.m. At the T-minus 9-minute hold, we'll adjust that hold period to sync up with the exact T0. This is an 11-day mission with nominal end-of-mission landing planned here for KSC on the afternoon of Monday, December 11th. In summary, our vehicle and ground systems continue to perform very well, and everyone here is focused, we're ready, and we're looking forward to launch of Endeavour Thursday evening. That's it.
Thank you, Pete. For payload status, Todd Corey.
Thank you, George. Good morning, everybody. I'm pleased to announce that as of Monday afternoon, we're all closed out with our payload closeouts in the payload bay. That would include the Italian-provided multi-purpose logistics module, the Goddard provided multiple applications customized hitchhiker, as well as a couple getaway special canisters that are installed on the orbiter sidewall, and also the Marshall design lightweight EMPAS carrier. The only work that we have remaining in front of us is the completion of the stow of 11 experiment lockers into the orbiter middeck, and we expect that work to be completed around midnight tonight. And of those experiments, 7 of them will be transferred up to the space station, and we have another 4 that will actually remain on the orbiter itself, go up and come down on this flight. And those contain, one of the experiment lockers has some quail eggs in it. There's 36 total, and the other 3 lockers contain a set of 24 mice that are being used for research on osteoporosis, the bone loss disease. And from that standpoint, once all that work's complete, we'll be ready to go. And at this time, we're not working any issues, and we're really looking forward to the launch on Thursday. Thanks.
Thank you, Todd. And for the weather forecast, Ed Priscilla.
Good morning. 3 items of improvement we're seeing today compared to the last couple of days. First, the Hurricane Center is forecasting Olga to gradually diminish, and that will help us with regard to the conditions in the SRB recovery area tomorrow evening. Additionally, as we kind of suspected yesterday, the upper low that's over Mexico, New Mexico, West Texas, looks like it's digging, and what that implies is a slower progression eastward of the frontal boundary. So all of these conditions seem to be giving us a sense that things look pretty good for tomorrow night. Given that, let's look into the tanking forecast. It looks like southeast winds tomorrow, just a few clouds around, maybe a little bit of cirrus in the area, and zero probability of anything constraining tanking for tomorrow. Looking to the launch forecast, just a few clouds at 3,000 feet and maybe some scattered cirrus. Wind southeast 12 to 18 knots, and the single concern we have right now is a slight chance of thunderstorm anvils if we get storms in the Gulf of Mexico. The way it appears right now, they probably will be too far west for the anvils to reach us, but we're still keeping 30% chance that that could occur. Looking to the recovery area, as I mentioned, we are expecting improving conditions as we work through the day today and into tomorrow, and tagged up with the Navy Norfolk this morning and estimating seas around 7 to 9 feet at launch time tomorrow evening. And with a long period of about 13 to 14 seconds in general, that will give them good conditions out in the recovery area tomorrow. Kona sites, the only concerns indicated by Dan Blue at SMG, slight chance of showers at Edwards Air Force Base. White Sands and Edwards otherwise good to go. With regard to towels on Thursday evening from Wayne Baggett, just a chance of fog at Zaragoza, and Marone and Ben Guerrier both looking very good. So at least 2 good towels tomorrow night. Looking to the delay forecast, just some scattered clouds around, good visibility. Looks like, as I mentioned, the front not getting into the area as we thought yesterday on Friday. Southwest winds 8 to 12 knots, and just a 10% chance we might have a low cloud ceiling in the area. For the Kona sites, both sites looking good for Friday. We do have to delay, and looking to the tails, all 3 sites looking good with just a slight chance of fog at Zaragoza. If we go into Saturday, conditions still looking good here. Again, just a slight chance of ceiling around 3,000 feet, and only a 10% chance for that. Looking to the Kona sites, both Kona sites at White Sands and Edwards in good shape. And for the towels, possibility of Zaragoza and Marone having some problems, Ben Guerrier good. So each day we've got at least one good towel. And I'll conclude at that point.
All right, thank you, Ed. And we'll begin with questions. Please give your name and affiliation when the microphone comes to you. Steve?
Steve, Sizewell, Florida today. My first question is for Todd. Have you packed any holiday items for the crew, any Christmas trees or Christmas hams or anything like that?
That I'm not quite sure if there's any Christmas items per se. There's inside the multi-purpose logistics module, there's various crew preference items. A lot of those items I don't personally see. It's typically private items, things from their family, children, wives, spouses, that sort of thing. So that possibly could be on there. I would imagine you'd think they may have a couple Christmas gifts or so, stowed away for the loved ones on board. But I can't really specifically answer yes or no on that one.
Thanks. And do you have to, in the event of a 24-hour scrub, do you have to roll the RSS back to make any of the changes in the experiments, like changing out the mice or anything like that, or can that be done with the RSS in the launch position?
Yeah, and Nick, correct me if I'm wrong, but they leave the RSS, in the retracted position, so there wouldn't be a need for them to have to move down in the position, because we get our access right through the crew cabin in the white room, which would be extended, so that'll provide the access for us.
That's correct.
Bill?
Bill Harwood, CBS for Ed. I know it's in your weather criteria online, and I just can't remember them. What is the rule on anvil? I mean, how far away do those guys have to be?
We need a 10-mile standoff on those.
The shuttle was scheduled to lift off on Friday night. Its mission, to ferry a fresh crew to the orbiting International Space Station. NASA says the delay was caused by worries about the shuttle's docking procedure with the space station. A member of the station's crew will take a spacewalk to move a wire now obstructing the docking collar. The shuttle launch is now scheduled for Tuesday. And hopefully weather won't interfere with that launch. So for your global weather report, let's join Femi Oke to have a look. Femi.
Thank you very much, Jimmy. I was just checking those pictures actually, and the sky was perfect for a launch on Friday, which is a shame we didn't get off. I'll have to come back to you for the Tuesday one. We don't go that far ahead in terms of accurate forecasting.
Wet weather continues towards western portions. Could see some rain in Oregon as well as Washington, all the way down into Los Angeles. High pressure system, though, throughout the eastern coast. Could see some scattered showers in the south. And temperature-wise, here it is, 16 degrees in New York, 26 in Miami, Dallas, expecting a high of 21.
Haben erneut einen Test für das geplante Raketenabwehrsystem ausgeführt. Wie eine Sprecherin des Pentagon sagte, verlief die Mission erfolgreich. Eine Abwehrrakete zerstörte über dem Pazifik eine Sprengstoffattrappe, die vom US-Stützpunkt Vandenberg in Kalifornien ausgestartet worden war. Es war der 5. Test im Rahmen des umstrittenen Raketenabwehrprogramms seit 1998.
Taken another step forward. A successful missile test took place on Monday night over the Pacific Ocean. 2 missiles were fired from around 8,000 kilometers apart. The intercept missile then found the other and destroyed it. The Pentagon says this demonstrates the success of technology which can intercept long-range ballistic missiles. It was the 3rd such successful test out of 5.
Die USA haben über dem Pazifik einen weiteren Test für das geplante Raketenabwehrprogramm erfolgreich abgeschlossen. Dabei traf eine Abwehrrakete eine 20 Minuten zuvor gestartete Interkontinentalrakete mit Sprengstoffattrappe. Durch den Aufprall in rund 230 Meter Höhe wurde die Attrappe zerstört. Damit sind bislang 3 von insgesamt 5 Tests im Rahmen des umstrittenen Raketenabwehrprogramms erfolgreich verlaufen.
And we do now have live pictures of our 7 astronauts as they're seated for their final meal prior to takeoff. Dan Taney will be our EVA specialist, as well as Linda Godwin, who will also be flying EVA. Mark Kelly is our pilot on this mission. And Dom Gorey, of course, is the commander of this flight. Also flying up is the Expedition 4 crew members, Yuri Onufrenko, and of course Carl Waltz and Dan Bursch. They will be spending the next several months in orbit on the International Space Station until the shuttle goes back up to retrieve. And they are coming out at this time. Commander Don Glory, leading his crew, pilot Mark Kelly, mission specialist Linda Godwin, Dan Taney, Carl Waltz, Yuri Onufrenko, and Dan Bursch.
Getting ready for their first mission since the September terror attacks. They're planning to take off within a couple of hours. CNN will carry the launch live. Thanks for watching.
Endeavour Houston for Dom. Just checking if you guys are ready for the simul voice check.
And Endeavour's ready.
Endeavour Houston for the whole crew, simul voice check.
CDR, about
The crew of the U.S. Space Shuttle Endeavour is getting ready for a liftoff and a trip to the International Space Station. Officials say security is the tightest ever for a space shuttle launch, and we'll carry that launch live when it's scheduled to happen in less than 15 minutes'
Shuttle
time.
Launch Control, and we are 3 minutes from picking up. Standing by to hear back from the shuttle training aircraft pilot Charlie Precourt for precipitation and clouds directly above the Space Shuttle Endeavour. 2 minutes remaining in our window.
NTD Houston Flight 212.
Go ahead, flight.
Yeah, NTD, at this time we have an update to our RTLS forecast. It's currently no-go. The observations, the official ops continue to be go. However, we have been getting reports from the STA pilot. He has increasing concerns with regard to RTLS landing weather. Again, we're still officially observed go and forecast no-go. It's my belief that the situation is too dynamic today for landing weather, and I think that's certainly the case. It's appearing to be the case for launch weather as well, so I'm going to recommend a no-go for launch at this time. Over.
I copy. And launch director NTD. Stand by. Range weather, launch director 212. Launch director, range weather 212, over. Okay, Ed, you got an update for us? Roger, sir. We are still red for flight 2 precipitation, over. Okay, copy.
45 seconds remaining in our window.
Launch director, the Alpha manager. I've copied all. I understand we're currently red for launch weather for precip and clouds, and we're currently red RTLS forecast for clouds that are below our limit ceiling. Furthermore, the STA pilot says his current observation is no-go in RTLS weather also. Based on this, the flight director and your recommendations, I request you go into a scrub recycle 24 hours. Yeah, copy. We're about ready to run out of the window anyway, so I copy and concur with that. NTD launch director. Go ahead, launch director. Okay, let's scrub our launch attempt today and go into 24, please. Okay, I copy that. And GLS, get cut off at this time, please.
Cutoff is given.
And with that, we have scrubbed our launch attempt for today. We will turn around for a 24-hour scrub turnaround. Our launch attempt tomorrow, Wednesday, December the 5th, will be at 5:19 p.m.
And attention all stations, as hold has occurred. All personnel turn to sequence 18 on page 1141.
And we have scrubbed for reasons of weather, weather at the launch pad, as well as weather at the return to the launch site. Stripped the shuttle landing facility. We had 2 reasons to scrub today. We carried it down to the very wire, but it just looked like the weather was not going to cooperate. Therefore, we have called a 24-hour scrub turnaround.
Weiter am Boden. Der Start der Endeavour zur internationalen Raumstation ISS ist erneut verschoben worden. Die NASA hatte den Countdown 5 Minuten vor dem Start wegen dichter Bewölkung abgesagt. Die Raumfähre hätte bereits vergangene Woche starten sollen. Luftfahrtexperten stoppten den Countdown, weil beim Andocken einer russischen Versorgungskapsel an die ISS Probleme aufgetreten waren.